Hello, folks. Welcome to Istio Weekly. Thank you all for joining today. I'm Orion Latizi. I'm joined by Peter Yashevich. Did I get that right? Close?
Close enough.
Sort of close? We even practiced this beforehand.
Oh,
and I wrote it down
multiple times.
phonetically. Peter is a software engineer, author, and international speaker. He has more than a decade of experience in the field of software development and tech in various roles such as QA, software engineering, and leading tech teams. He's been working in the cloud native space for the past couple of years and delivering tech talks and workshops around the world. He's authored and co-authored a number of books, most recently, Cloud Native, Using Containers, Functions, and Data to Build Next Generation Applications. Today, we'll be talking about certificate management in Istio, and Peter will take you through the details of some of the different ways to set up SSL certificates in your Istio ingress gateway. So with no further ado, Peter, please take the mic.
Thank you. This was an awesome intro. So as Orion said, we'll be talking about SSL certificates and how you can set them up on your Istio ingress gateway. Now, we all know that SSL certs are a must today, right? They create an encrypted channel between the client and the server to prevent eavesdropping. The certificate also gives your websites more credibility, as well as, in case you didn't know that, it increases your ranking position on Google. Also, with services such as Let's Encrypt and SSL for free, there's really no more excuses for not having an SSL certificate on your site. The SSL certificate has to be installed on the server side, so there's no need for the client certificate. However, when the client also needs to present a valid certificate to the server, in that scenario, we are talking about mutual TLS. The Istio ingress gateway can be configured to do both. It can present an SSL certificate as well as do mutual TLS if needed. We'll only be talking about presenting a server certificate today, and there's really only three high-level things that we need to do. First, we need to get the SSL certificate and the key file. There are multiple ways to do this. I'll show you how to create a self-signed certificates that are only to be used for testing, by the way. Don't use this in production, as well as how you can use services I mentioned before, the SSL for free and Let's Encrypt, to get the real signed SSL certificate you can use for your websites and your workloads. Second thing is that we need to make the certificate and the key file accessible to the ingress gateway. Ultimately, this is done by creating a Kubernetes secret that contains that certificate and that key. I'll show you how to create the certificate, or the secret file rather, manually, as well as how to automate this process using a tool called cert-manager. This is where the tool will automatically bring down the certificate to your cluster, and it will create a Kubernetes secret. In the end, whichever way you choose to go, however, you should automate this, you will end up with a Kubernetes secret. Finally, once we have the certificate and the key file inside the cluster, we also need to create and configure the ingress gateway. We'll do this with the gateway resource. And what we'll do there in the resource is we will point to the Kubernetes secret that holds the certificate and the key. That way, when the requests come in, the ingress gateway knows which certificate to present. So I'll show you the three different approaches on how to deal with SSL certificate. The first one will be using a self-signed certificate. Now, this approach does not require you to have an actual domain name, and it is only meant for testing. And I'm going to bring this up multiple times. Only for testing, don't do this in production. Note that the self-signed certificate is not signed by a certificate authority, and it doesn't really provide security features that certificates signed by a real certificate authority provide. Now, this approach, the first one, will be fully manual. We will manually create the certificate and the secret that will contain the certificate and the key. For the second approach, we will use SSL for free website to create a certificate for an actual domain name. So we will create, I have a domain name, we will then go and download the certificate created on SSL for free website, and then we will manually create a Kubernetes secret. Finally, the last approach, we will install the cert-manager. This is a tool that we can install in Kubernetes. We will configure the different resources, the issuer resource, for example, and then create a Kubernetes resource called certificate that will automatically go and talk to Let's Encrypt. It'll request the certificate and do the validation and then create the Kubernetes secret. All right, so let's go to the first two demos. And as soon as I find a way to switch my windows and share my Cloud Shell window. All right. So we'll go with the first approach. However, before we start creating certificates and everything else, I'll just deploy a sample Hello World application. I have a Kubernetes cluster, and I've already installed Istio 1.10 on it. And I've also already labeled the default namespace for injection. So I'll just deploy the simple Hello World deployment with a corresponding service. And then in order to be able to access this Hello World deployment that's running in the cluster, we also need to create a public gateway. So note that this gateway has the host set to start, and we're listening on port 80. And in order to actually reach that deployment, we also need a virtual service. And we're attaching that public gateway to this virtual service and then routing it to the Hello World workload that's running in the cluster. Finally, I'll just get the IP address of the ingress gateway. And now if we curl to the ingress IP, you'll notice I get back the response saying hello world. Similarly, if I go to the IP address, I get hello world, but also notice that this is not secure because we're not using any certificates here. All right, so let's start with the simplest scenario first, where we will manually create a self-signed certificate. So the first thing that you have to do here, and again, this is just for testing, you have to pick a domain that you want to use, so then we can go and create a certificate, a self-signed certificate for it. So I'll use a domain called tetradelabs.dev. And what I'll do is I'll actually hook up a subdomain called hello. So we'll configure the gateway with a host called hello.tetradelabs.dev, and then we'll present that self-signed certificate. Let me also create a separate folder where I'll store these certificates. Okay, and the first thing that we'll do, we will use OpenSSL, and we will create the root certificate that's called tetradelabs.dev.crt, and then the private key used for signing the certificate. So let's do this one. I actually have to go into the folder and then rerun it here. There we go. So get the certificate and the key. Next thing, we need to do a certificate signing request and a corresponding key here. And then finally, using the certificate authority that we've created with the first command and the certificate signing request, we can create our own self-signed certificate. So let's do this one. There's a lot of OpenSSL commands, and don't worry, we will post this in a GitHub repo, so you can go through it again yourself. All right, so we have the certificate here. Notice it's for the subdomain hello.tetradelabs.dev. Now, as we said, the second step that we have to do is, once we have the certificate and the key, we need to create a Kubernetes secret to store these two files inside the cluster. So we will create the secret in the Istio system namespace and then reference it later from our gateway resource. So I'm creating a TLS secret called tetradelabs-credential, and I'm passing in the key as well as the certificate file value. So once this is created, we have to go and update the gateway resource next. Let's do this one. The only change that we did here is we updated the port and protocols to be HTTPS. And we also added this TLS field here where we're setting the TLS to simple. It's not mutual, it's simple. And then specifying the credential name. And this is the actual secret name that we just created in the previous step. Finally, we're also setting the host to hello.tetradelabs.dev. So configure the gateway. And then we also need to configure the virtual service again to update the host name. So the only update here is this host name. So let's do this. So this is configured. Now let's try it out. I will use a curl command, and I will set the host header to hello.tetradelabs.dev, and then I'll tell curl to resolve hello.tetradelabs.dev to the ingress IP address. Additionally, we are also presenting the certificate authority cert we created. So if we do this, you'll notice we get back the response. Let me just do it again with the verbose mode on. So we'll actually see that the certificate, the server certificate that we created was actually presented when we made a request. So let's see how we can now use a service called SSL for free to create a real certificate for a real domain. Now, if you're following this later, or if you want to try this out, you will need an actual and a real domain name registered. And for this demo, I registered a domain called istioweekly.com. So I have already created the certificate bundle on the Zero SSL or SSL for free website. So I've already have it there and I've already downloaded it. The way that you can do it yourself is you have to sign up for the website. It's free. You click new certificate. And then let's say your new domain is called very nicely as my new domain.com. And we'll click the next step. And then you have the ability to pick 90-day certificate or 1 year. Just going to go with 90. Next step, next step. And then once this goes through, now this is the step where you have to verify your domain. So you can't just go make up domain names that you haven't registered and try to obtain certificates for it, right? You have to go and verify your domain. There are a couple of ways that you could do it. You could use email verification. You can update the CNAME record in your DNS with these specific values, or you can upload, you can do like an HTTP file upload to validate it that way. So I've already done this before, and I already have Istio weekly certs. Let me clear the screen here. I've already downloaded the bundle here, and there are 3 files. There's a CA bundle, certificate, and the private key. So if we want to use this, we just follow the same thing that we did before. We already have the certificates. What we need to do next is we need to create a Kubernetes secret to hold the certificate and the private key, and then update the gateway and virtual service. So I'll use a similar command as I did before. I'm naming the secret istioweekly-credential, passing in the key and the certificate, and just creating the secret. Then we will update the gateway again. So the difference here is the port, the protocol, still the same thing. The difference is in the credential name, as well as this istioweekly.com host name. Let's do this one. And of course, same thing for the virtual service. We've only updated the hosts here. Okay, and this is configured. So if I open a new site here and I go to istioweekly.com, you'll notice that I get back the same response as I did before. It says hello world. But then additionally, if I click this padlock icon here, you'll notice that it says connection is secure. I can click on the certificate, and I know this is kind of hard to read, but it actually does say that the Istio Weekly has a valid certificate that was issued by Zero SSL RSA Domain Secure Sites CA. So we have a valid certificate for our domain name. Okay, so let me switch back to a couple of more slides. I don't have a lot of them left, only a couple.
So Peter, one of the things we might want to discuss is like how the name resolution works. You got a few new domain names, you got a new top level or a new subdomain. How does that play into this picture?
So yeah, what I did beforehand, and I think I have this is what I have on the next slide here. So in addition to all the other changes that I did before, I also, I validated domain and all those things. I also had to update the DNS records on the domain. So I went to my domain registrar, which is name.com in my case, and then I had to create a record with the value of istioweekly.com, and then point that a record to the ingress IP address, the external IP address of my ingress gateway. So that way, when I type in istioweekly.com, it will resolve it to the actual ingress gateway external IP address. Notice I also have the hello.istioweekly.com, and this is what I'll use in my last demo. Now, this scenario where we got the real certificate, we downloaded it, we created a secret, it works great, we have the real certificate. However, the problem here is that you probably don't want to be manually updating your certificates before they expire, right? Like you don't want to, I mean, you can do it if you want. You can put like reminders in your calendar to update this manually, but everything would be so much better if this could be done automatically for us. And I'm pretty sure everyone knows where I'm getting at next. And yes, we're lucky because there's a tool called cert-manager that can help us with that. So what cert-manager does is you install it in Kubernetes cluster, and then the cert-manager talks to the certificate authority. In our case, our certificate authority will be the Let's Encrypt server. And then cert-manager will then go talk to the Let's Encrypt server, request a certificate, and then finally create a secret with that certificate and the key. The communication that happens between the cert-manager and Let's Encrypt uses a protocol called ACME. So ACME stands for Automatic Certificate Management Environment. And this protocol defines how the certificate authority can automate the verification step. Remember the email verification, the DNS verification, adding the DNS record that we saw in zero SSL or SSL for free example, right? There are 3 different ways to validate the ownership in that case. In case of when you're using cert-manager and ACME protocol, we will use ACME to actually automate this verification. So we don't have to like send an email, copy the code, or go manually to the DNS and add an entry there. So when the cert-manager gets the certificate from Let's Encrypt needs to validate that we actually own the domain name we are requesting the certificate for. And the way this is done is through so-called challenges that are defined by this ACME standard. There are 2 types of challenges. The HTTP challenge is the most common one. And the way that it works is that Let's Encrypt gives a token to the ACME client. So ACME client is something that will be running in our Kubernetes cluster as part of the cert-manager tool. And that client in the cluster will then host that file at a known address that's accessible to Let's Encrypt servers. So once that file is in place, Let's Encrypt will try to retrieve it. And if our client responds with the correct responses, the validation succeeds and the certificate is issued. Now, all this is going to be automated for us by the cert-manager. So we don't necessarily need any knowledge about the domain configuration, and this is fairly easy to automate as well. However, one of the downsides here is that we can't really issue wildcard certificates. So we couldn't issue a certificate that's star.istioweekly, for example, right? But we will be able to issue a certificate called hello.istioweekly.com. The second challenge is called the DNS challenge. And this one will ask you to prove that you actually control the DNS for the domain name by adding a specific value in a TXT record under that domain name. So just like we set up the A records before I showed in the previous slide, in order to solve this DNS challenge, we would have to add a specific TXT entry with a specific value in the same place. This approach is harder to configure, but it does allow you to issue wildcard certificates, for example. You could use this DNS challenge only if your DNS provider has an API that you can use to update the DNS records. Then you would take that DNS provider's API credentials, configure them, store them as a secret in your cluster, and then the cert-manager will use them and talk to your DNS provider through that API to update the TXT record when needed by the ACME protocol to solve the challenge. Know that with DNS and when you're using DNS, there's always some propagation time, and that's the reason that I had those A records set up beforehand. That means it just might take a while for the certificates to get issued. And it all depends on how slow or fast your DNS provider is updated. The other downside of this approach is that you need to store the DNS provider's API credentials on your cluster, right? And then finally, if your DNS doesn't provide, DNS provider does not have an API, then, well, too bad, you can't even use this DNS approach. So you have to use the HTTP approach instead. Okay, so let me switch back again to the demo, and we'll do this last demo. There's my Cloud Shell. Perfect. All right, so the first thing that we'll do is I will install the cert-manager. So I'm just using kubectl apply and then applying the cert-manager YAML file. So this might take a little while. It shouldn't be too long though. But this will create like various custom resources. Everything will be in the cert-manager namespace. There's a bunch of cluster roles, a couple of webhooks, injectors, and all these different things. So once this is done, what we can do next is we can create a resource called issuer, and that resource will tie our email address to the specific server on the Let's Encrypt side. So there's an option of using the production server or the staging server. For example, if you're just testing or if you're setting things up, you should probably be using staging server just so you don't hit any rate limiting. So let's just make sure that the pods are actually running. Yeah, so there's 3 pods that are running here for cert-manager. So that means that the thing is ready. So let's create an issuer, and we'll talk through the issuer. Okay, so as I mentioned, there's 2 servers that you could use, and this is on the line here. The one is pointing to the production. This one is the production one, but there's also the staging one, just for testing if you want to use it. The private key secret reference is just a secret that holds the private key that identifies me or my email as a user of Let's Encrypt. And this is all handled automatically. You don't have to create any keys or secrets or anything like that. Then in the solver section down here, we're specifying that we want to use the HTTP challenge. And additionally, and this is important because we're using Istio, we are specifying a annotation called class Istio. And this is the annotation that will get added to the ingress resource that cert-manager will create for us. So what will happen once I create this issuer and then actually request a certificate, the cert-manager will spin up a pod that will host a token file, and then it will also configure an ingress resource that will point to that pod. So that way, when Let's Encrypt servers go and talk to the file token, they have access to the actual token, and they can validate it and then issue the certificate. There's also, I think there's another type of issuer called cluster issuer. So you can have like specific issuers that only live in specific namespaces, or you can have like a global cluster issuer as well that you can reference anywhere. Okay, so I have this issuer, so let's create an actual certificate resource. Now note that this is all done with YAML, right? You don't have to, there's no files that you have to create separately. It's just YAML that you're applying to the cluster. So I'm creating a certificate called hello-istioweekly.com. I'm specifying a secret name. So this is the secret where I'm basically telling cert-manager, hey, once you retrieve the certificate and the key, this is where I want you to store them in this secret. I'm referencing the issuer that we've created earlier, and I'm just saying I want a certificate for hello.istioweekly.com. So let's do this. So once this is created, that's where the whole request workflow kicks in. So this is it creates another resource gets created called certificate request, and then the pod gets spun up, the ingress resource gets created, and cert-manager talks to Let's Encrypt server to actually issue the certificate. So if we list the certificate, you'll notice I only have one, and this is the hello istioweekly.com, the one that we've created. It's saying that it's ready. let's also look at the scribe certificate. So here at the bottom, you'll see that it started issuing the certificate because the secret did not exist. Created a temporary resource first, then it created a resource called certificate request. And then this resource then did the other work. Ingress gateway was created, pod was created. The challenge was successfully solved, and the certificate was issued. So once this is issued, the only thing left to do is to, just like we did before, update our gateway resource, right? Everything is the same. The difference is in the credential name that we're using as well as the host. So let's do this. And then we also need to update the virtual service just with the correct host name. So just setting the host name to hello.istioweekly.com. So let's do this. So this is configured. And now if we go to hello.istioweekly.com, you'll notice I get the hello world back again. I get this nice padlock here that's telling me that the connection is secure. And if I look at the details, and let me actually go down here in details, you'll notice down here that the organization is called Let's Encrypt, which is just saying that Let's Encrypt is the CA that issued this, this certificate. All right, so this was for my demo. I'm going to switch back to slides.
We have a question here, Peter.
Sure.
So one of the questions is, how did you expose the Istio ingress gateway? Did you use a node port? Was there the load balancer? How did that work?
Yeah, so the Istio ingress gateway, let me actually share back my my screen. There you go. Yeah, so the Istio ingress gateway is already like exposed by default when you install Istio, right? So whenever you install Istio, the Istio ingress gateway is deployed as a load balancer service in Kubernetes, and you automatically get an external IP for it already, right? So there was no, like, I didn't have to do anything special to get this exposed. It was just a matter of installing Istio. Note that I did install the demo profile of Istio, which includes the ingress gateway and the egress gateway. So this is just exposed as a load balancer. There's no like node port or anything like that. Yeah.
Awesome.
All right.
We have a couple of other questions, if we've got time.
Sure. Yeah. I think
so. What's good guidance on how long certificate expiration should be set?
Well, I mean, from the security standpoint, I think you should aim for shortest time possible, meaning that you should not like issue certificates that live forever, right? Because that can, like, once that gets compromised, then you shouldn't be doing that, right? You should have, like, the certificates should be short-lived, especially, I mean, the key here is, of course, having the automation to renew them, having the automation to create them, right? If you have that in place, I mean, in the end, you do not necessarily have to worry about it too much. I mean, sure, you should make sure that you have an overview over all your certificates, over all their expiry dates and all that, and make sure that the certificates actually get renewed by the tooling. But I think as short as like a couple of months, maybe, right? Specifically, like if we're talking about TLS certs for like doing simple TLS, maybe a couple of months. But if you're doing like workload to workload, if you're doing mutual TLS, in Istio, I think the expiration time is set to 1 hour, right? So it's very, very short.
And this question is maybe already been answered to a certain extent, but like, can we discuss some strategies for avoiding expired certificates and the unpleasantness that ensues from that?
Yeah, I mean, one of the strategies is to basically have automation in place, right? So you don't get so there's no unpleasant surprises when you wake up in the morning and you notice that you don't have that nice padlock is gone from your website and people are actually getting warnings. The other thing is to actually have like have a way to track your certificates, as I mentioned. Make sure that you know their status at all times, when they expire, when they were created. Yeah, but I think the key here is having automation in place that allows you to do this automatically, so you don't have to worry about it too much.
Excellent. Well, thanks, Peter, for putting the session together. We hope that you've all found this useful. And also, we hope you join us in June for the next episode on deploying Istio in multiple gateways. You can find the Istio weekly schedule and all about the Tetrate Istio distro on and the community there at istio.tetratelabs.io. We've put all the tutorial material up on GitHub at github.io/tetratelabs/istioweekly, and links to that and other resources are available at the community page at istio.tetratelabs.io. Also, check in with us on the Get Istio channel on the Istio Slack workspace, slack.istio.io, or leave comments on this video. We look forward to seeing you next time when we cover deploying Istio in multiple gateways, and we'll see you then.